In this video, we're going to discuss how to solve trigonometric equations that are quadratic in form. Many of the trigonometric equations we study can be solved using techniques that we already know. If the equation has a second-degree trigonometric term, then we may be able to use factoring or the quadratic formula to solve the equation. And this problem says the following. Solve the equation 2 cosine squared theta plus cosine theta minus 1 equals 0 in the interval 0 less than or equal to theta less than 2 pi. Now this equation is quadratic in terms of cosine theta. So let's make a side-by-side comparison to a quadratic equation in terms of x in order to see how we can solve this trigonometric equation using factoring. First, I'm going to rewrite the trigonometric equation on the far left-hand side of my page. 2 cosine squared theta plus cosine theta minus 1 equals 0. Now next to this equation, on the right-hand side of my page, let's write the equation 2x squared plus x minus 1 equals 0, where x is equal to cosine theta. And next, on the right-hand side, let's note the quadratic trinomial in terms of x will factor as the product of two binomial factors. So the equation 2x squared plus x minus 1 equals 0 becomes the quantity 2x minus 1 times the quantity x plus 1 equals 0. Now, on the left-hand side with our trigonometric equation, the quadratic trinomial in terms of cosine theta is going to factor in the exact same way. So we can write the quantity 2 cosine theta minus 1 times the quantity cosine theta plus 1 equals 0. Now I'm back to the right-hand side. We're going to use the zero product property. Right? In other words, if two factors are multiplied and their product is 0, then we know that one or both of those factors must equal 0. So we take each factor and set it equal to 0. So we write 2x minus 1 equals 0 on x plus 1 equals 0. We then solve both of these equations for x and we get x equals 1/2 and x equals negative 1. Now, similarly, we could follow the same process with the trigonometric equation and set each factor equal to 0, and we would write 2 cosine theta minus 1 equals 0 and cosine theta plus 1 equals 0. Then we're going to solve each equation for the cosine term, and we would write cosine theta equals 1/2 and cosine theta equals negative 1. Now, in the interval of 0 less than or equal to theta less than 2 pi, we know that cosine theta equals 1/2 for theta equals pi over 3 and 5 pi over 3. And we also know cosine theta equals negative 1 for theta equals pi. So our given trigonometric equation of 2 cosine squared theta plus cosine theta minus 1 equals 0 has a solution set of pi over 3, pi, and 5 pi over 3.